In this video, we're going to be talking about special segments in circles. So we're going to first start off by looking at chord segments, then we're going to look at secant segments, and finally we're going to touch upon tangent segments. Now, in this case, we're looking at two chords. We have chord AC and chord BD. But as you can see, the chords are intersecting each other, so they are cutting each other into separate chord segments. So we have one chord segment here, AE, another EC. We have one chord segment here, BE, and another ED. And so we have a theorem that shows the relationship between all of these segments, and this is the theorem. AE multiplied by EC. So what I just did here is I just named the two segments that make up the first chord, AE and EC, will be equal to BE times ED. That's equal to BE times ED. And if I wanted to throw in another chord that intersects with these chords, so for example, if I wanted to just throw this in here, then it would be equal to whatever this is times whatever this is. So this is a general thing that always happens with the segments of chords in circles. Now let's take a look at the segments of secants. Okay, so let's start off by talking about what a secant segment is. A secant segment is a segment with exactly one endpoint on the circle. So for example, in AB, the segment AB, B is on the circle. That's the endpoint that's on the circle. In the segment AC, the endpoint that's on the circle is C. So that is also a secant segment. And we have AD, and what's the last one? Correct, AE. So those are all segments with one endpoint on the circle. All right, so now that we know what a secant segment is, let's talk about what it does. If we have two secants that are crossing each other, intersecting each other outside of the circle, so we have this happening here outside of the circle, then the secant segments have a special relationship. The longer secant segment, so AC, times its shorter secant segment, AB, will be equal to, and I can say the same exact phrase again, the longer secant segment, AE, times the shorter secant segment, AD. I'll write that down. So we have AC, and again, these are measures, not the names, but the measures. So AC times AB will be equal to AE times AD. And that's a given. So we can do a quick example just to make sure that we understand. Okay, so in this example, we're being asked to find x. And remember that the longer secant segment, so we're here, the longer secant segment times the shorter secant segment will be equal to the longer secant segment times the shorter secant segment. So let's put the letters down. So we have the longer secant segment on top, which is JG, multiplied by the shorter one, which is JH, will be equal to the longer one at the bottom, JL, times the shorter one at the bottom, JK. All right, and I'm not joking. Ha. Okay, anyway, so JG, the measurement of JG, is 8 plus x, times the measurement of JH, which is 8, is equal to JL. So JL is 10 and 16 together. So that is 10 and 6, which is 16. And JK is 6. All right, so we're on a roll here. So all we have to do is solve, simplify and solve, so I can distribute. And I get that 64 plus 8x is equal to 96. We can go ahead and take 64 from both sides, and we get that 8x is equal to 32. And finally, we can divide both sides by 8, and we get that x is equal to 4. All right, and we've used the secant segments in order to find x. All right, so now that we've looked at chord segments and secant segments, we're going to move on to the last step, which is the tangent segment. So a tangent segment is exactly what it sounds like. It is a segment of a tangent with exactly one endpoint on the circle. So if I were to try to extend this line, it would extend and not cross into the circle. It is a tangent line that I would be extending. But imagine that I took that tangent line and I just cut everything off beyond that point that it touches the circle. So that's what a tangent segment is. All right, so how does that relate to anything? So let's say our tangent segment is meeting or intersecting with a secant segment. So let's call this L and M so we can work with those labels. All right, so it's very similar to what we learned before, but with a little bit of an exciting twist. Or long segment, so JM multiplied by our short segment of the secant, which is JL, will be equal to our tangent segment, so JK, times, yes, I said times, or tangent segment, JK. So we can just actually say JK squared. All right, so this is a rule that is pretty interesting, I think. So let us say that this is 5 and 2. So this part here is 5. This part here is 2. Then I could figure out what JK is by plugging in here. So JM would be equal to 7, JL would be equal to 2, and that would be equal to JK squared. So JK squared then would be 14, and JK would be the square root of 14. And you can go ahead and simplify that or turn it into a decimal, your choice. But that's how tangent segments work. That's it for now.